All right, so we're back at composition of functions. The difference between algebra 2 and pre-calc composition is all parent functions are up for grabs, right? All functions are up for grab, whereas algebra 2, we only focused with linear, quadratic, and absolute value. That was it. Now you have the whole spectrum to deal with. Cool? That's all the difference is. The same skills are going to be applied. So making sure we're comfortable reading it and following through. So here we have f is composed of g of x, right? So this is telling me that f is the x is going to be substituted with whatever g of x is, right? So in this problem, what we have here is g of x equals 1 over x plus 2. So in f, I'm replacing all of my x's with 1 over x plus 2. And then I'm going to simplify. So what that ends up looking like is we have 1 over x plus 2 squared minus 3 times 1 over x plus 2. Agreed? G of x is a function. G of x equals 1 over x plus 2. It's just substitution, right? So now that I've done that, I'm now going to simplify this. Simplify means get rid of unnecessary parentheses, combining like terms, and having only one denominator, okay? So I'm going to distribute the power. So the power goes to the numerator and to the denominator. When I distribute to the denominator, that means I now have 2 of them. So this is 1 over x plus 2 times, oops. Times x plus 2. Yes. Okay, can we, I will, yeah. Minus, when you're distributing a whole number to a fraction, that whole number only applies to the numerator, right? So that's 3 times 1, which is 3. So we have 3 over x plus 2. Okay, now, in order to combine fractions, we have to have a common denominator. Are these denominators the same? No. So in order for them to be the same, what would I have to do to this denominator? I would have squared, right? I have to multiply by it times its self. So I have x plus 2. What I do to the denominator, I have to do to the numerator. Now that their denominators are the same, I can write one single function. Okay, one term. So 1 minus 3 times x plus 2 over x plus 2 squared. Cannot eliminate, I just put it there. So you wouldn't eliminate something that you just added. That's thing number 1. And thing number 2, you can't eliminate when it's adding and subtracting terms. You only can eliminate factors. I'm adding and subtracting in the numerator, so I cannot eliminate anything. You only can eliminate factors, which means you're multiplying. Okay. All right. So then once I distribute, I'm left with 1 minus 3x minus 6 all over x plus 2 squared. Keep simplifying, and I'm left with negative 3x minus 5 all over x plus 2 squared. And that is my, I don't think it's going to make you. At least I wouldn't. I mean, you can expand, but I feel like at this point, we all can see that that's x squared plus 4x plus 4. No.
Yeah. Do B. Would be the hardest kind of complicated? Like the hardest kind of
Y'all can do whichever ones you want. You can work ahead. You don't have to depend on me.
So I'm saying, like,
yeah.
That's what we're asking. Can we do all the examples?
No.
So I was saying, can you do me like you would walk through that?
It doesn't matter whichever one. You want me to walk through it with you?
Yeah, like do.
Oh, sure.
I'm not doing all the examples.
Oh, yeah. I was about to let you do B. Then we were going to do C. Then you were going to do D.
Oh, okay. Like, are we gonna do all the examples together? And you're like, no.
No, we're not. You were going to do B and C. Oh, I was like, we're not. I was like,
Okay.
oh, no. Okay, gotcha. I'm also like,
Yeah, no, I could see them on No.
I'm just like, try not to go crazy. And I'm like, what? No. You're gonna do it. Okay, anyways, domain. The domain here. What is our domain restriction for a rational function? Denominator what? Cannot equal 0. That is our domain restriction, right? So what is this, all real numbers?
But, it can't equal -2, right?
It would be -2. -2 plus 2 is 0. And 0 squared is 0. So our domain is all real numbers, but x cannot equal -2. Oh, that's lovely. X, yeah, x cannot be -2, because if I get x equals -2, then it becomes an undefined situation. So the domain is all real numbers, but x cannot equal -2. That's
So is it just -2?
-2 is the only number that this rational function cannot let x be. It's your domain restriction. What would make the denominator equal to 0? Is what you're looking at. That's our domain restriction for rationals. All right. Okay, so you're now going to do G composed of f of x. What does G composed of f of x tells us?
That whatever is f for G.
Exactly. Whatever f of x is replacing the G with the x and G, right? So it becomes G composed of f of x. Okay. What does f of x equal? So that's what you're going to be doing. And then, yeah.
Yeah, like.
That's it. Do you have any unnecessary parentheses? Have you combined like terms? Is it one denominator? Those are the 3 things you're checking for. All right. This one should have been kind of quick. Are we ready? All right. So G of x is 1 over x plus 2. However, I'm replacing all of my x's with x squared minus 3x. So we end up with x squared plus 2. Yes? Do I have any unnecessary parentheses? Do I have any like terms to combine? Do I have more than one denominator? So this is my
That's your answer.
answer.
Great.
Okay, I'm not adding or subtracting 2 fractions. Okay, now domain restriction here. What is my domain restriction?
Oh, we're on to C.
No, you still gotta tell me the domain. What is the domain here? X cannot equal what? And what else? And 1.
Oh, we can break it into the factor.
X cannot equal 2 and x cannot equal 1. If I plug 2 or 1 into this, my denominator would equal 0. Going back to factoring, this factors out to become x minus 2 times x minus 1. Yeah, it kind of conveniently connected it, so I just let it be. All right. Okay. Set up and start. F composed of h of x. And we're going to go over it. I'm trying to stay calm about this computer. Why I've had my audiobook in when I'm by myself. I'll block it out.
Like buzzing your entire. I hear it.
No, it's the inside of the computer.
It's trying to talk to you. Maybe there's trash in there, like.
I mean, we need to get like some canned air.
Sorry, the exponent, the cancellation error, right?
Square, yes, unnecessary.
Sorry.
All right, ready?
My
Good. All right, so let's talk about what we have here. So, this ends up becoming f composed of h of x, which is the square root of x. So everywhere there's an x, it now becomes square root. So we have the square root of x squared minus 3 times the square root of x. It sets itself free, exactly. So we get x minus 3 square root of x.
Thank you.
Are there any like terms to combine? No. So we are done there. What is our domain restriction?
I don't know, positive three?
What is the rule for square roots? It can't be negative, so to make sure that this is negative, never negative, it can't be negative. How do I write that? X has to be greater than or equal to 0. That ensures that I will not have a negative underneath my square root. Does that make sense? All right, D, give it a shot. H composed of f of x.
Where would the X be?
Oh, wait, I think I got it.
Oh my God.
Really. It sounds like it's a name.
All right, so here we go. So we have H is composed of now x squared minus 3x. So we're substituting that in and we get the square root of x squared minus 3x. That is our composed function. The next part is determining the domain. We know that x squared minus 3x has to be greater than or equal to 0. So if I have to be greater than or equal to 0, what are my limitations? Well, that goes back to your factoring skills. We have x and x minus 3. So both of these have to be greater than or equal to 0. So what are our restrictions here? So it's 0 and 3 to some degree, right?
Is that the little like squiggly line?
Yeah, so if I have, when I'm looking at this quadratic, I know that it goes from 0 to 3 is where I cross the x-axis.
Yeah.
Does that make sense?
It's negative.
There you go. Good job, Anna. So your domain is from negative infinity to 0. Yep, because it's equal to, and then 3 to infinity. Well,
I was ready. Yeah.